Figure 1 shows a sketch of y equals f of x. Point A has coordinates 3, 2, and we're asked to then sketch the graphs of, first of all, y equals f of x minus 1. This is going to be a translation. You don't need to write this down necessarily, but I'm going to translation by minus 1 in the y direction, or in vector form, just translation by 0, minus 1. So every point is essentially going to go down by 1. So my curve will look a little bit like this. So I'll still have my value of the minimum at x equals 3, but now the values, instead of being 2, is going to be at 1. And then I just need to label it A, 3, 1. Then for f of x over 2, I'm timesing by a half, which means it's a stretch in the x direction by 2. Let me just talk about why that is. So if I have x and f of x and f of x over 2, then let's say I put in 1. Actually, I'll go up in, I'll write 2, so then I'd get f of 2 here, but here I'd only get f of 1. If I put in, say, 4, I'd get f of 4 here, whereas I get f of 2 here. So you can see the value where I did have f of 2 was x equals 2, and now it's at x equals 4. It's actually kind of, the x value has doubled, and that would be the case for other ones, like 8, for example. I'd get f of 8 here. This would be f of 4. So f of 4 would now, it was at x equals 4, now it's at x equals 8. So you can see why it's a stretch by 2 rather than by, say, a half, hopefully. Okay, so that means that my point is going to go from being 3, 2 to actually 6, 2. It's going to jump to here. Still be the same for y. And then I'm just going to show that it's kind of spread out. There we go, nicely done.